Alright, this video is for Harper. This is from fall semester 2018. Working on how to flow a drawing along a surface for a quick maquette to figure out the three-quarter view of a cuff bangle. This is the image of Harper's design that we have traced into Rhino, and now I'll make a maquette. First thing I need to do is bring this into three-dimensional space. To do that, I'm going to grab all of her curves for the top view, and I'm going to move them into the center. I'm going to put these all on one color layer. I'll put them on the green. Enter, going to use center snap to grab the center of this box, put them at 0. Next thing I'm going to do is grab the front view of Harper's cuff, and I'm going to rotate that up into position for a front view. Like so. Now I'm going to extrude Harper's front view so that it is the proper thickness. Solid option and snap. Like so. There's a basic maquette of Harper's cuff. Now I need to be able to flow the lines onto this, so I'm going to have to explode this. So I have this surface. I need a line down the center of that surface. The easiest way to get that line for me is going to be to extract an isocurve using mid-snap. Come under here. Actually, I don't even need that. I already have the curve here in her drawing. I'll just explode her front view. So I have the curve already in place. Hang on one second. Okay. Sorry. I hit cut accidentally. Alright, there we go. So there's the curve. When you flow along curve, which is the command we're going to use, you have to have a flat reference curve and a three-dimensional target curve. The reference curve and the target curve have to be the same length. It's also helpful if they have the same math, meaning the same number of control points and the same degree of curvature. I'm going to check what the math on this curve is now by applying a rebuild command. Right now this curve has 9 points and it's a second degree curve. That is not enough. Well, it will work, but if it were any more complex it wouldn't work, what we're trying to flow. So to be a good example, I'm going to give us plenty of points here. I'm going to go to 36, and the 4 is fine for the degree. I'm going to give the same math to this curve. And the numbers are still here. That curve was 2 and 1. It'll also be 36 and 4. So if I turn the control points on for these two curves, they will look very similar. And that's what Rhino uses when it's flowing geometry. It's taking this point, comparing it to that point, taking this point, comparing it to that point, and so on. And that's why, if you have just very few points, it's hard for Rhino to give you a good flow. Okay? As far as how many points, that's a matter of experience. I have found that for most circles or ellipses, 36 is fine. If it's a closed circle or an ellipse, which this is not, but if it is, I also like 36 because it's divisible by 4. And if you have a point count that's divisible by 4, it'll keep your quadrants, which are useful for snapping to later. So basically it's a work habit. I'm going to select Parker's top view, and I'm going to flow it along curve. Transform, flow along curve. Actually, I don't want to flow this. I'll take that curve out. Transform, flow along curve. Base curve. This is the original curve. Pick near the end. Target curve. pick near the end. Oh, it's locked. And you'll see that Parker's curves have been moved and wrapped around the surface of the object. So I don't have her original top view curves in the way. I'm going to go back into the top view, and I will move them up and out of the way, just to tidy things up. So there are Parker's curves. Now I can turn off these curves, move this up into position to join its partners. I'm going to put these curves on a different layer. I'll use the light blue. Turn off this curves layer so we can see clearly what we have. Turn back on the surface object. I am going to grab all of these and have Rhino make a drawing for Harper. I'm sorry, I keep getting your name wrong. What's important here, though, before I do that, is when you make a 3/4 view, you lose accurate scale. Rhino doesn't have anything here that is actual size to grab. So in order to alleviate that, we're going to put a reference object in here that'll make it easy for Rhino, or at least for us, to get this actual size after the fact. I find the most useful object is a sphere, because a sphere is the same size from every direction. Solid object, sphere center radius. I'm going to pick quad or mid. Going to grab the very top because this is the point where it's the most important to have it actual size. And 10 millimeters should work. So I'll do a 10 millimeter sphere. Okay. I'm going to now take all of these. I'm going to select a view that I think is nice. And I'm going to go to Make 2D Drawing, Current View, and hit OK. And Rhino will make a drawing. Okay? I'm going to group those lines together so I can select them all at once easily. And I made a mistake. Sorry. Before you do this, you have to save the view because you're going to want to get the same view twice. So to get the same view twice, either you have to make sure you don't revolve, or you have to go to Views, Set View, Name Views, and then save this view. Call it anything you want. I'll call it 34-1 for 3/4 view 1. Now I have that view available whenever I want it. Do the same process again. Control A, Make 2D Drawing, OK. Group. Going to turn off the orange and the blue. Going to select the red ball. Make 2D Drawing, Current View, OK. Don't need to group that. Going to turn off the ball. I want to lock the 4 views so that I can't select them accidentally. Bring back the drawing. Make sure my view is the right view. So I can come here, Set View, pick 341 off the bottom. It didn't move, but if it had, that would restore it. Select everything. Notice the background drawing is not selected because I locked it. Dimension, Make 2 Drawing. OK. And group. Alright, so I have several drawings to play with here. Unlock this. Going to separate these drawings from each other a little bit. join that together. So I have 3 pieces here. The main purpose for this piece is to be able to come in here and restore this circle. Rhino got lost with part of the circle here. But see, it's not going to work. I'd hoped that Rhino would preserve the scale. It didn't. So, okay. I can't use that cheat that I would like to use. By the way, I've gone into top viewport from perspective. I'm going to draw a simple circle. Diameter. Do it right in the middle. 10 millimeters. This is how big this needs to be. I'm going to grab this. And I'm going to do transform, orient 2 points. Scale equals yes. Copy no. It would be lovely if enough of this circle survived that I could grab either a top quadrant or a bottom quadrant or a side to side. I can't. But I can grab these 2 quadrants. Unfortunately, those will not align with this quadrant very well. But I can still use it to get the size. I'm going to re-rotate that drawing. And it doesn't really matter if I match the exact rotation I had before, because this is just an illustration. So I could actually change the rotation if I liked a better angle. There we go. Only problem with this, of course, is it has a great big ball in the middle of it. Going to grab our second clear drawing here, and I'm going to do the same orient 2 points command. Copy no, scale yes, 3D. Going to go to my end snap, and I can grab any 2 points on here that I know I can duplicate here. And the most obvious are here. Target 1, reference 1, reference 2, target 1, target 2. The exact same drawing. Throw away the drawing without the red ball. And that is an actual size 3/4 view of Harper's cuff. Put it someplace nice in the middle. And that's it. This will match up with her flattened top view. It is actual size based on her drawing. So now what she needs to do is she needs to take these lines out of Rhino, either by printing them out or exporting them as an Adobe Illustrator file and taking them into Painter or Photoshop, and trace and draw her pattern as per her original design. And that is it.